Hi everyone, Alex is here. Micro-Frontends. Let's start. What is micro-frontends? So micro-frontends are parts of your application that you're importing dynamically, and not like, for example, React is doing with different components. Not. It's totally different repositories that are taken by fetch and are combined in one application. So just imagine that you have one project, for example, an admin panel. And this admin panel takes a lot of components, it works with a lot of pages. And what you're doing right now, you're just creating a couple of repositories, and each of these repository is taking a huge feature or a huge component that you're working in your admin panel. It could be different tabs, pages, etc. That is micro-frontend. So you are taking these components in different repositories, fetching them with your main page, main repository, and taking them and combining. This is how it should work. So how will really have benefits from that? Which maybe problems we will have from that? We have some. So basically, I'll show you how does it work a little bit later, but you just should understand that it will think a little bit. What it can give us? Firstly, even different repositories, we have really independence in creating, in deploying, and even if, for example, we'll have a problem in our repositories, for example, something will fail, the main project won't fail. So basically, when you're working in such a way, main project is trying to be mainly untouched. So that's why mostly it will work because there won't be a lot of changes. And when you work in different repositories with these different parts of your front end, for example, you can have header in different repository. You really can make deployments how you want that. It can be different from the another team. Also, it's clear ownership of this or that project. Because when you have one project, it's a little bit complicated to understand who has an ownership, because mostly different parts of your components have different owners, and that's sometimes a problem. Also, there is really big, amazingly big benefit, that is you can just use how many frameworks you want. Each framework can be different repository and you can combine them. For example, Swatel, Angular, Vue, and React, you can combine them in one project, and each repository will have different framework and you'll combine them. Why it will work? Because basically you're not combining the code, you're combining the result, and all the results from these frameworks is plain JS file, and plain JS file will work wherever you want. So that's really big benefit here, because when, for example, some features can be better developed in one programming language and another in the another one, so you can combine these things. It's also better optimization with bundlers. And also you don't need to take things that users won't use. For example, you're creating an admin panel and you have really advanced analytics. These analytics can take, for example, 150 megabytes or maybe more of your memory just to be loaded. And you know that this specific thing won't be popular in most of your users. So you can make that separate in a separate repository, just to load that when the user have permission, have experience, wants to take this thing. So that will really help you to optimize such bundles. Also, when you're taking, for example, such project, it will be really better to refactor that, because when you have one big application, it's always harder to refactor that. You just should understand where all these components, if I will change this component or another one, how it will impact for another places in your project. Or for example, you can make a different story in your project, and you always should know how it will be understood with another components in your project. So when you have different repositories, you won't have such collisions. That's benefits. And they're really big, especially for the specific projects. I think that you won't use that for every time, for every day, but in some specific things you can. For example, you can create video editor online, and you can create a page where only guests can check. For example, it will be simple video, and you can create advanced mode where you can edit this video online. So you can create these functions, this page, in a separate repository, and then load that when user will need that. So it will optimize your performance. So what is downsides here? Because they're also here. When we're trying to debug a problem, the problem is that you should check that in different projects. And when you're running debugger, for example, in Chrome, you'll see the problem instantly, that it is showing you how it's going from one file to another file, and that could be different repositories. So you should have all the copies of such repositories. And if there are a lot of them, you should have all of them to discover why a specific thing doesn't work. Also, when you're taking, for example, settings, I think that the biggest downside here is to setting up such project, because it's really, it's so big problem here, I think. So first of all, you should understand that SSR will be different working here, because when you're using simple frameworks that will run all of your application at once, you can write SSR that will bundle all the code at once. But how you can do that when your components are remote repositories? So you should somehow, before even loading the project, you should make a request to take that. And that's the problems. It will be a little bit tricky here. It is possible, but it's tricky. So you should understand that it will be big downside, and you should have down on that, discover that. But once you will make that, it will be much better. Also, you should understand that, for example, some missed properties. For example, you can miss shared property, and it will make big problem with, for example, versions of different packages. For example, they can be not synced, and when you finally try to bundle all of these projects, you'll have error because they have different versions. This is one small thing, and there are a lot of things that should be understood. Also, big problem, requests. You'll probably have a lot of requests, but if you will make that really careful, for example, you can have one project, main project, with the specific most used features, and some advanced one that will be run really rarely, but they're important for someone, and they're heavy. You can make them in different repository. Or, for example, with the specific feature that we should have specific programming language, it also can work. But that's the problem, that you should make such requests. Yes, we have a big benefit that if something will fail, all of your project will still work. That's incredible. But you should understand that that's requests that you should run. Also, when you're trying to bundle that, CI/CD will take bigger time and resources because it should take all of that projects. It should take requests, discover how it should bundle that. So it will be really complicated. So settings are the most complicated things right now here. Also, you should have all of the versions of your repositories to run your project. Yes, you can use the default one, for example, that are running on the stage or testing field environment. But basically, it sometimes you will need to run all of them at once to discover how do they work. And once more, it can be easy, but if you make great settings of that, you'll make a run environment that will run all of them locally with one command, it will be better. But sometimes, you see, it can be complicated. Also, settings about safety, because cores, for example, you should understand some specific headers that will be sent, and that will be more risky because when you have different repositories, you know that anyone can make a request, and more requests you have is bigger chances that you will be failed or someone will hack your system. So that's why a lot of developers are trying to minimize such thing, but it's not ideally working. So you should really understand that and keep in mind that such problems could be. And also sometimes it's not really easy with design thing because each command can work with little bit their design. But ideally, you should have separate library, separate repository that will be linked to those one, and it will be easier to all of these projects just to use the same components and the style library. That's important. That's how it works. That's benefits, problems here. And basically, before understanding if you need to use that or not, first you should understand if there are any big part of your application that should be in a different repository. That should be loaded for different users, not all of them, rarely. And that's a huge thing. If answer will no, probably you won't need to do that. But if answer will yes, we should discover how we can implement it. At least the very basic way of doing it. Let's start. Here we'll see two folders, CLI and Micro-Frontends. What is different between them? So basically, when I'm trying to show you how does it, all such things works, I'm trying to separate CLI commands, and it will be easier for you to understand them. So let's discover Micro-Frontends folder. It will open that. It's a small understanding of different repositories. Host, remote folder, remote header. Honestly speaking, you can have here as much folders you should have. But first you should understand that the main project calls host. All the others that are taken by host are remote. So we have host, remote header, and remote footer. Let's work with that. Firstly, let's understand how this host is working. But before, you know what, even before that, let's discover their folder system and how does it work. So basically, all of them initially will have two folders, two files, all of them in an equal weight. Let's discover what do they have in public one. All of them have index.html file. Let's open that. Host app, nothing special. Remote footer. We'll have just different titles, but similar deep. Let's go further. So public file index.html will just need to be only for importing because it will be the part that is imported by our host. So they're importing HTML file. And that is just a simple template. Sometimes Webpack can create that by its own, but in our case, it will be easier just to create a separate one. And let's go further with our SRC files. Our SRC files, all of them, have JS file, index.js file, like main file, that will create this bundle that are taking all the components and will create one bundle, and JS6 files. So JS6 files will be main to take all of the things and be imported by index.js. So index.js is importing such JS6 files. And let's firstly look our host. How our app.js JS6 is working. So we're importing React, we're importing Suspense and Lazy. And header and footer, as you can see, are imported with fetch with lazy mode. So lazy, what does it mean? It means that firstly, it will run app file firstly. So it will run all the things that app file should have. And after that, if they will have memory, if they will have time, they will start working with header. And also, when you have, for example, a button, click to load more information. When you will click on that, it will also lazy run some, for example, additional components. And here, while we should have suspense, suspense have fallback. So when we're taking header like a component, it automatically understands that it cannot be run, and we can just wrap it with suspense. It will automatically understand was it okay or not, and if it wasn't, we can have fallback, for example, loading here, and until it won't be loading, we'll have just fallback loading header. Then we have the same with footer and just a simple main text in the middle of your application. And then we have index.js. It just basically just taking out the React things, creates root, creates our file, and just by our get element by ID, so by our index.html file, it just takes that div ID root and puts inside that what does it see from our application. That's all. It will go to our footer.js. No, let's go firstly to header. Header.js. Nothing special. Just we're importing React, we're having function that we're exporting, and we have here a simple header with some styles and H1 micro-frontend. Nothing interesting, I'll speak. Just simple HTML in our JS6, in our React. How do we import that? Also, the same way we're doing that with our host. Just importing React, create root, header that we're taking. And inside our index.html file, the same ID root, we're putting our element. This is default settings, nothing special here on speaking. And the same we have with footer. So we have footer, so we have here a little bit different styles, a little bit different tags, and we're importing them in our index.js the same way. And it takes the same index.html in the same way, putting that in the div file ID root. Nothing interesting here. Public SRC are not interesting here. We're just making separate folders with our parts of our application. That's all. It's like creating a simple React project in this case. And the most interesting thing comes in a Webpack config file. But before that, let's discover what we should have in our package.json. So package.json will be nearly equal in all the files. The one thing that will be different, for example, name. All the packages we're taking will be the same, and basically it's better to have all of them the same, because if it will be not, it will have problems. So once more, if you'll be able to make one place with all the package.jsons, it will be incredible. I don't know if you'll be able to do that so easily, but that will be really better to have. So what we have in all these package.jsons, we have dependencies. Dependencies are going to production. So this is two libraries that will be working in our project in real life. This is dev dependencies that will be running only in development mode. So only when we will run them, and development mode is here. So mode development, if we won't use it, it will be only taking these dependencies. But we're taking development mode and it will run a little bit more things. So it will also take Webpack, like additional dependencies. So dependencies will be also working. So additional dependencies, Webpack, HTML, Webpack plugin. So these things, why do we need them? It will help us to work with our application. So first it will show us some logs. It will show us how we can bundle our application, because when we will build that, because in production we should build it on, we'll build it, we'll just take our dependence. But Babel will run that in development mode, so we can change something and will automatically reconfigure our application. So for making such automatic reconfiguration, to see logs, to see errors, all such things, we should have develop dependencies. And there will be, once more, the same for all the applications. The same. The only one thing that will be a little bit the same, a little bit different, and it's the most important here, is our Webpack application. So let's finally get it. We have Webpack config.js, and they will take all of them. You can see all of them. We'll take Pass, HTML plugin, and the model federation plugin. This plugin will help us to create micro-frontends. HTML plugin will just help us to take HTML, to put our JavaScript into our HTML, and etc. Not really hard here. It is basic for Webpack plugin. We're interested in model federation plugin. So basically, Webpack configuration should take an entry. So one JavaScript file that is taking all the other. In our case, in each of the project, it will be src index.js. Then we're running that basically in development mode, so it will be easier for us to just take it down. But we should have different ports. So each port will have its application. So our computer can have a lot of ports. Each port makes its thing. So one port is taken, for example, Visual Studio Code. Another one is held in Chrome browser. Another one is working with your keyboard or your mouse, or your voice and microphone, and etc. So we have a lot of ports, more than 65,000, as I remember. But for working with our, for example, application, we can use 3,000. And 3,001, 3,002 are basically empty. Sometimes it can give you an error that this port is being taken, so you can just increase the number by 1. And at some point, you find a free port, 99.9% of that. So you're taking this 3,000, 3,002, 3,000. It will be our port on which our application will run. Output, public dir output. This is important for our model federation plugin, because it will automatically see what is our public file folder. For example, in this case, it will be coder, and it should automatically understand where it should take our applications. Then we have rules. So rules will run every time, like, for example, our models, in this case, it's index.js files, are changed. So we're testing if our folder that we are, for example, in host or in remote folder, or in remote header, is file JS or JSX. So it will not work with HTML file, it won't work with JSON file or any others that are not this one. So if it is regex, it's trying to take the extension of the file. So dot, and it will be JS or JSX, and $, it means in the variant. So in the variant of the file, we'll have such extensions. we're loading baby loader. So baby loader will make a bundle. So what is a bundle? So you see such beautiful code, and it will make in one line harder to understand, but it will be better for your application to understand JavaScript file. And also it will make all of the ununderstandable for that files, for example, TS file, JS6 files, or view file, or any others to a simple JavaScript file, because browsers understand on the HTML, CSS, and JavaScript. That's why we should have such Babel loaders. And it will take presets, so it will understand that it won't take just a simple JavaScript, because with simple JavaScript, you can just use Babel loader. But when you're using React, Vue, they have different syntaxes, they have different unique functions. And to make that better bundle, so it will be more optimized, it will be faster, it will be cleaner. You just should better to have specific bundler. And in our way, it will be specific present for React. It will call Babel preset React. And it will be the same, for example, for your remote and header. Let's see. And here we're going to the plugins, to the most interesting thing here. And what we have been looking for model refrigeration plugin. So in our remote footer and header, we're telling that this file is header app. It will create and take remote entry.js. So it will make that by itself. So it will be JavaScript file with your entries. And it will take that inside this file, it will write that we have header file that is inside src header JSON. That's why we should have public path out. So it will understand that our basic folder will be here, for example, or coder, and it will understand where it should find our src file. So it will be in Micro-Frontends, host, or remote footer, or in our case, in remote header. And it will understand where to find this specific JSX file. And then what is the most important that I was telling to you about shared? So shared, you're taking which libraries you're taking. So for dependencies, you're taking React and React DOM. So how it will work? Singleton, what does it mean? If we have this specific library in different of our application, for example, we have here in remote header, we have it here in remote footer, and even we have it here in host, so React DOM. So we have that everywhere in our application. We're telling that it won't be duplicated. It will be only one represents of that, because we can make different represents of that. We can write singleton false, and it will just run two such modules, and will write specific prefix for each of such libraries. So it will be important and taken by specific repository. But here, I can write singleton true, so it means it will be shared with all of your applications and it won't be duplicated. But what is eager true? Eager true is when you should run that in synchronic mode. So basically, how does our shared thing works? Basically, when you're taking your application, it tries firstly to load the component that it needs. And when we need, for example, firstly, to run our src file, this one, lazy, for example, it will try, based on this code, find any libraries that are be important here. And here is the problem, that we're importing lazy, for example, and we're importing header and footer. For example, once more, lazy is React function, and we won't be able to take any information before loading React, because React is our fundamental program. So our program is being created on React. If we'll have an application with simple JS and we'll be importing our React project, okay, we cannot write in this equal true. We can equal false or just empty that. It will be default false. But when we're trying to take our project or just to run that, firstly, initially, even without loading any things, we'll have a problem because it should be automatically run from the very beginning. And that's the problem, that it is unavailable. React is unavailable by that time. The scope of shared application is empty currently because we don't have this. And when we're running Eagle2, from the very beginning, when it's trying to run bundle of index.js, it will be also run bundle of React. So it won't work until first appearance inside of this bundle, because we won't be able to create initial code without React. So firstly, we should run React and bundle the JS, and it will work, because without of that, Babel Webpack won't understand how to work with this file. What is lazy? What is functional? What is suspense? What is React? It won't understand that. So that's why, firstly, we must import our libraries when we're importing our files that will be base our application. And that's all here. And our remote, once more, footer and header are the same here. We're taking HTML plugin. It will be also in host. We're just taking our public index.html file, and we'll put all of our bundle. We'll connect it automatically to our index.html file. And we're working with our JS and JS6 files, so it will try to find them out. And that's how remote header and footer works. So what is the difference with remote header? Remote header doesn't have file name and exposes, because it doesn't need to provide how to import host. We don't need to import our host. We should take information from remotes. So we don't need to share this host. We should take the information. So that's why I have simple remote object. And we are calling it header app and footer app. That will be taken from here. Header app, slash header footer. That's a specific component that we're taking. We can take all of the page, but we can take specific component also. So what does it mean? We're taking header app, footer app, that is called here, footer app and header app. So it depends on this name. From where? From our local host. So it will be our server, remote server. And this remote server, we're taking auto-generated. So you don't see here any remote entry.js. Yes, because it is created instantly by our Webpack, so we won't see that. That's how it works. So it will dynamically take that from our internet, in our case, from our local host. And to work with that, we just should, firstly, go to our remote header, install all the dependencies, and start our project. Let's make that. We're taking that, we have our terminal open, clicking that, running that. Then we're clicking plus, so we'll add our remote footer. And it's better to wait until our bundlers will be installed, like all of the models will be installed, our projects will be run, as there will be success, as you can see, so they have been created. We can see here our node models. And after that, it's better to run host. You can run host right now, even before running them, but it will be better. It will be less problems if you will be running that afterwards. So we're hitting start, and you see it works. Let's go to our website. So we have localhost 301. It's our header. You can see it's just our header. 302. It's just our footer. So your teams can work in different such repositories. And then we have 3000. That is basically everything combined. In this page, it is specific, this one. That's how Micro-Frontends works. Thanks everyone for watching this video. I'm really happy to see you here and looking forward to make new videos for you. All the best for you. Bye.